All right, Liam, this is Bo. I'm going to try to send you answers to those problems. Problem 30, I'm going to cruise through these. You need to be able to translate words into equations. The first problem that I'm going to do, 30, says 3 times the sum of a number and 4. So that's 3 times the sum. I'm going to have to put that in parentheses of some number, we'll call it x, and 4. So let's think about why that captures the first statement. That is 3 times the sum of a number and 4. So that's the sum of a number and 4, and that's 3 times it. Okay, now we're going to say is means equals, so equals 8 less than 1/2 the number. Well, 1/2 the number we can write like that, and it's 8 less than half the number. So I got to subtract 8 from that. All right, now this is just solving an algebraic equation, and I'm going to distribute that 3 through the parentheses. I'm assuming, I haven't worked with you before, I'm assuming your math is your ability to solve an algebraic equation is solid. I'm going to go ahead and get x by itself. I'm going to subtract 1/2 x from both sides. That's going to give me 3x minus half of x. That is 2.5 x. I'm going to do it the way I would do it, which is to write 2.5 as 5/2 times x. Now I'm going to subtract 12 from both sides, and that's going to give me 5/2 x equals -20. I'm doing this the way I would do it. I would say I could divide by 5/2, but I would rather multiply by the reciprocal. So I'm going to multiply by 2/5 on the left, because I know that when I multiply 2/5 times 5/2, I'm going to get 1, which is my goal. But if I multiply the left side by 2/5, I've got to multiply the right by 2/5. And now I've got just x on the left. And when I do this math, multiplying -20 by 2/5, the end result is going to be I have -8. All right, so that's problem 30. I'm going to keep going. All right, so this is problem 31. And now I have a square and a rectangle with the same perimeters. So I'm going to go ahead and draw out a rectangle, and I'll draw out a square. And they don't look like they have the same perimeters, but we'll deal with that. The length of a side of the square is 4x minus 1. The length of the rectangle is 2x plus 1. And the width is x plus 2. Now the key part of the problem is that the two perimeters are the same. So let's think about what the perimeter of this square would be. Well, if each side is 4x minus 1, I've got to multiply that by 4 to get so there's the perimeter of the square is going to be 4 times 4x minus 1, and that is 16x minus 4. The perimeter of the rectangle is I'm going to have to add 2 of those x plus 2's and 2 of those 2x plus 1's, and I'm going to go ahead and say what that result would be. That is going to be 6x. I'm going to have 2 of those plus 1's and 2 of those plus 2's, and that's going to give me 6x plus 6. You're going to have to make sure you can duplicate that. Now, if I'm going to subtract 6x from both sides, and I'm going to add 4 to both sides. That's going to give me 10x equals 10, and then x equals 1. All right, now my phone just shut down. Let me see where we're at. Not even sure I answered. I got to make sure that that answers the question. Were we just supposed to solve for x, or were we supposed to do something else? Hold on. Hi, crud. Sorry, I'm trying to get. All right, so there we were just supposed to find x. So we did that. Then we have 32 we're going to do next. Hopefully this is working for you, Liam. All right, I'm going to do 32. So a movie club charges a one-time membership fee of $25. And then they get to purchase movies for $7 each. Another club doesn't charge a membership fee but charges $12 each. How many movies must a member purchase for the cost of the two clubs to be equal? So we got to write an equation. So this is the cost. We're going to write the cost in the first club is going to be $25 that you just have to pay, and then $7 for each movie. So we'll say $7 for X movies. And the cost of the second club is just equal to 12 times X. And the question is, at what point are those two values equal? So what we do next is we set those two equations equal to each other. So 25 plus 7x equals 12x. And then I solve for x. I'm going to subtract 7x from both sides. And that's going to give us 25 equals 5x. Divide by 5. X equals 5. We can plug that result back in up here and make sure that it's true, that those two costs would be equal to each other. If I let x equal 5, I get 25 plus 7 times 5 is 60. And down here, I just get 12 times 5, which is also 60. So that's correct. All right, that is problem 32. And then we're going to do problem 33. All right, so problem 33 says describe the difference between an equation that is defined as an identity and an equation that has no solution. Okay, so an identity is something that's always true. And if I wrote something like 2x plus 3 equals 2x plus 3, that's an identity. Because no matter what value of x I plug into that equation, it's always true. X equals 5 would make 13 equals 13. X equals 2 would make 7 equals 7. It's true for all x. Something that has no solution has to have some kind of contradiction to it. And really, frankly, we could take this same example and barely change it. I could say this is for the no solution case. I could say 2x plus 3 equals 2x plus 4. Well, that would be like saying, 3 more than twice the amount of money I have in the bank is equal to 4 more than twice the amount of money I have in the bank, and that doesn't make sense. In fact, if we try to solve this, well, we'll look at what happens both up here when we try to solve that. In the first case where it was an identity, if I try to solve that, I'm going to subtract 2x from both sides, I'm going to subtract 3 from both sides, and I'm going to get 0 equals 0, which is what you get when you have an identity. If I try to solve the second equation, I'm going to subtract 2x from both sides, I'm going to subtract 3 from both sides, and I end up with 0 equals 1, which is not true. And that tells me there's no solution. So that's 32. Or 33, I think that was. All right, I'm going to the next group of problems. I'm going to try to cruise through them. All right, let's see here, Liam. All right, real quickly, I'm going to do 5, 8, 9, 10, and 11. I'm trying to get this all on one video, which means I got to keep, because I can only make them 15 minutes long, so I'm going to try to keep this thing rocking. Well, I'm running out of time, but let's see. All right, 5 says 4t plus 9 equals negative 8t minus 13. I like to try to keep my numbers, my variables positive, so I'm going to add 8t to both sides. I'll do this one step at a time. That's going to give me 12t on the left. And if I haven't done anything with the numbers yet, with the constants, I'm going to have that. Then I'm going to subtract 9 from both sides. And that's going to give me 12t equals negative 22. So we get ugly numbers here. But unless I wrote the problem down wrong, and I didn't, it's just ugly numbers. I'm going to divide both sides by 12, whether I like the numbers or not. I get negative 22 over 12, which is negative 11 over 6. And you have to get used to the fact that sometimes problems don't have nice solutions. So that is number 5. And now I'm going to erase that. And we'll go to 8. And I'm about to have to, I'll try to get, well, I'm gonna send this, and then I'll send you another video with the last problems. All right, Liam.